Free public Wi-Fi is great until you actually need it. It's slow, insecure, and collapses at peak time.
They promise free, unlimited, and secure Wi-Fi, but too often, none of those hold. Our solution?
Hey, we are Satoshi Blacks. Thank you for letting us in the hackathon, and I'm going to present to you what we have done as a project for this hackathon submission. We referred it to as a WiFiMeter. So basically, what it does is that this application basically sits on a router, and it basically lets packet go at the kernel level through it, but with a condition of a micropayment. So like a micropayment condition means basically like for every 100k bytes or every 1000 bytes, we are going to charge you for a certain amount. So it can be used as a public Wi-Fi router anywhere where there is public Wi-Fi, with the incentive of basically adding economics to the system. So, and it basically merges with something known as Wi-Fi Vault, which we also have created. What it does is that it maintains local UTXOs in that subnet, and whenever our WiFiMeter requests it to, like we need, like you are getting low on data, we need that data, we need more data, so it asks for a request to the wallet, asking for more payment as a micro payment, and it funds that particular machine which is in that router's subnet. So basically the routers, whoever machine is connected to the routers, it will add to its state that okay, now we have added some particular amount which is configurable. So let's say you have said that 100 satoshis for every 10 MB. So it will request 100 satoshis, and it will fill up that state for it, like it will increase the 10 MB threshold, whatever it has before, and it will go again until you stop paying. When you stop paying, basically means that you will not be able to access the internet, as simple as that. So we can have a running condition. Let me build it. So it basically works over eBPF. eBPF is a kernel virtual machine. Basically eBPF is a code which runs over a kernel virtual machine, and it lets you attach hooks around a certain kernel networking subsystems or other places like trace points and things like that. We are using it for the networking subsystem. So we have attached the XDP hook, and we are basically capturing every single packet, and we have the ownership of those packets. So we can do whatever we want with those packets. We can extract information, and we can either reject them, either pass it to the kernel networking stack again, or whatever we can do. We can even mutate the packets, but we don't do. We only. And the most interesting thing is that everything is secure, because if at the application level you are not using encryption, that is the only insecurity which is there. So that is also we don't get like that insecurity is everywhere. So I will start. So this is some configuration parameters you need to pass, like where is the config. So config is nothing but something where you can provide. So for these many bytes, we will be charging like 100 satoshis. So very simple. So for every, I think this is like for every 10 MB or I think 1 or 10 MB, we are going to charge 100 satoshis, and this is the admin WIF which you need to pass. So this thing you can run on any router, any Linux based router. 90% of the routers are Linux based. So we have started the machine. Now there is, so currently this system is working as a router, and there are machines which is connected to this machine, like this machine, which is a separate machine on my internet, which is basically sending, like this machine, my main machine is the router for that machine. So currently its size is like 20 MB or something, and you will see how the size. I will try to do some surfing on the internet on that machine, and our wallet sit there on that machine for that transfer of funds. So you will see when so the threshold amount is 10 MB. So whenever I reach 10 MB, it will request for a payment. So basically we are using payment channels. So we basically ask for an input, and until that input expires, like until the amount of that input becomes vanished, we use that transaction to just change the output amount and get it signed back from the wallet. So the wallet maintains all that particular scenario. So you see so it is a little, like packets are being used continuously. I can also download something to make it even more faster. So whenever it hits that 10 MB mark, it will ask for the request again. So you see, currently I am downloading Redis, and it will keep asking that wallet to fund it whenever it reaches a certain threshold. Now you see, I have already downloaded the full Redis. My Redis is installed, so now it will again become slow. So this is how it works, and we will show you the wallet also with a new descriptive video from the other system. Thank you.
So, yeah, again back from Satoshi Blacks. So this is the UI which we are using for our WiFiMeter. So this is nothing but a desktop wallet which basically communicate with our WiFiMeter application, and WiFiMeter application request this desktop wallet to have the transaction signed and funded using payment channels. So here I will show you a quick demo on how it works. So again, this system has a default gateway to my router machine. So I will start, and now you will see the data usage you are using and the cost of satoshis you are basically you have paid for the amount you have used. So here you go here. I am also logging out transaction ID so that I can show you a specific transaction which happened. So you can see the transactions are happening, and as you go and you use a lot more data, here you will get all the updates. So you get updates in chunk of 1 MB actually.